Selamat sejahtera to Professor Madya, Dr. Ahmad Zaki, and everyone. Today, I would like to talk about the project-based learning of subject microcontroller. Our project title is Automatic Straight Light. First, let me introduce our group members. Muhammad Hilman bin Jamaluddin, Kelvin Hian, and me, Ong Kang Wei. We are from 3PEKM, Session 2. In this video, we will present the introduction of automatic straight light, explanation of programming code, simulation, and conclusion of this project. First, the introduction. Automatic straight light is a simple yet effective design that automatically turns on and off straight light. Automatic straight light do not require human switching on and off. Because of manually turn on and off the straight light will cause high power consumption. Because the person in charge will forget to turn off when there is light. And when the darkness reaches a particular level, the straight light automatically turns on. And where is another source of light, the straight light will be automatic turn off. Next, Kelvin will explain the programming code.
Hi, my name is Kelvin Hian. Today I'm going to explain about the programming of the code. Now, first we declare the integer of the light at the data type and the long integer for the count. Now we start with void interrupt first. So T1 count we will disable the timer 1. C and T++ is increment of the count. TMR1L equal to 0. This one is the lowest bit. This one is the timer 1 highest bit. PI1 is the flag of the timer 1, so we set F0. So the T1 count we declare again is we enable again. PIE is for we need to turn on the interrupt. INT count for the interrupt to set the global and the PIE interrupt register. So this one is the LCD module connection. LCD RS we connect to the RC0. LCD enable we connect to RC1. LCD D4 data 4 we connect to RC2. LCD D5 we connect to RC3. LCD D6 we connect to RC4. LCD D7 we connect to RC5. So for the S bit RS direction we set at the trace C, so we will connect the line and the C pin C. So this one is for the C0. Enable is connect to the pin C1, and data 4 we connect to the C2, data 5 we connect to C3, data 6 we connect to C4, data 7 we connect to C5. The touch is set for the input or output. Next we will declare the LCD character. TST1 11 is 11 character but the LCD can set as 16 because we use 16 times 2 LCD. TST1 we set daytime, TST2 we set nighttime, TST3 we set as street light on, TST4 we set as street light off. Character for the I is for the use as the counter. Void read LDR. When we connect LDR, we need to convert from the ADC analog. So when the light formula is 100 minus ADC value divided by 10.24. If the light greater or equal to 80, the port B pin 2 will become 0. Then LCD will clear, then LCD will come out as the daytime. LCD out the second row TXT4. So the street light we will show at the LCD is street light off. Else port B pin 2 equal to 1. 1 means the light will on. So LCD will come out as the TXT2 at the night time and the street light is on. Next, white main. So the white main is the important part for the function of the controller for looping. So we set trace B as 0. 0 is output. Then TMR, the flag is set as before. Then trace B is 0. Port B 0. 0 is 0 volt for the port B. Trace C 0 as the output. Port C 0 as 0 volt. Then LCD initialize the LCD CMD as will clear the display of LCD. Then LCD CMD LCD cursor off will off the switch of the cursor. Then ADC initial to initialize the ADC module. So Y1 if the CNT equal to 154. 154 is for 2 seconds. 2 seconds. Then the port B will inverse. Then the counter will become 0. Then it will read the LDR value for the program looping. That's all from me. Thank you.
Assalamualaikum to Dr. Zaki. I am Muhammad Himan. Today I would like to explain about the schematic circuit for the automatic street light using the purchase aid. So this is the component that we use for this project. So this is the PIC 60F877A, the main component. So this is the microcontroller lah. So for the PIC we need to declare the input and output. So for the port A we declare the input, port B and port C we declare as the output, and then we declare master clear for the reset PIC. And also we have the crystal oscillator. So crystal oscillator to fit the frequency system of the microcontroller. So crystal oscillator of 1 MHz is shoot the PIC system. So this is the oscilloscope. Oscilloscope we can check the waveform, especially we use for the delay or timer. So for port B we have the output. So for the output we have the transistor, diode, relay, LED and battery. So for the output using the BC848B transistor, this is the NPN transistor, is controlled by gate which is connected to the pin 35. As the connector turn on the pin 35, the transistor will allow the current to flow through the relay 1. So when the relay 1 is the charge, the lamp circuit is closed. So the gate is closed and the current will flow to the LED. But for the PIC only provide 5 volt. So that is not enough for the LED to turn on. So that's why we need to put the battery as the extra source for the support or to turn on the LED. So port C is the for the LCD. So LCD we show the that time is day or night, and also we show the street light is on or off. Okay, let's run the simulation. Okay, when we run the simulation, when the sun near to the LDR sensor will send the input to the PIC, and PIC will provide the output and send to the relay, and relay turn on gate and current cannot flow to the LED, so LED is turned off. And also LCD will show that time is daytime and street light is off. Okay, when the sun is far from the LDR sensor, okay, LDR sensor is sent to the input to the PIC, and PIC will provide the output to the relay, and relay can turn off the gate and the current can flow to the LED and LED will light up, and LCD and show the that time is night time and street light is on. So for the delay or timer, we use the timer one for 2 seconds. So let's check the from the digital oscilloscope. Okay, this is the waveform. So this is the 5 volt and this is 0 volt. So let's measure. So from here to here. So for the interval or delay is take time for 2 seconds. So this is the turn on the operation and this is the turn off the operation. So we use the delay for the ADR sensor. So ADR sensor we collect data for 2 seconds in every operation. So every night, every day, ADR we function to collect data is every 2 seconds lah. Okay, that's all from me. Thank you, Doctor.
In the conclusion, the proposed straight line automation system is a cost-effective and the safest solution is to reduce the power usage. It helps us to get rid of today's world problem of manual switching, and the most importantly, primary cost and maintenance may be minimized simply. This technology may be easily deployed in street lighting, smart cities, home automation, agriculture field monitoring, timely automated light, parking light of colleges and industries. That's all from us. We will end our video here. Thank you for watching.